Okay, we're back. And this one's considered the following. You're given something, certainly a conic section, at least you hope it's a conic section. It says find a standard form of the equation of the ellipse. And this is something that you've studied in Math 120. Let's go through that. And I'm going to collect the x's together first. That's 49x squared. Let's see, minus 98x. They're generally pretty kind about the numbers, by the way. And then it's going to be plus 36y squared. Let's see, minus 360y. And then you're going to put the constant on the side, which is 815. I'm going to factor it now. It's 49. And what comes out from this is x squared. The reason is it makes the completing square a little bit easier for me. That'd be 2x. To complete the square nut, I'd have to take half of minus 2, which is minus 1, and square it, which would be plus 1. Now, the problem most students have is they don't realize if you do that, you've actually added 49. So now it's going to be 815 plus 49 now. Let me do the other one. Plus 36. This would be y squared minus 10y. Now, a little more complicated because half of minus 10 is minus 5. When you square, you get 25. Now, what you're doing now is you're going to add 36 times 25 to both sides. All right, let's do the work now. What do you get? Let's see. You get 49 times a perfect square. And that perfect square is going to be x minus 1 squared. Plus, well, you're going to factor this guy. It's 36. Wow, that's a tough one, isn't it? No, not really. It's just y minus 5. Now, I know a lot of students really have a tough time with this, but I'm going to point out arithmetic's a really important skill set to have. All right? So I'm going to do 815 plus 49. So that's going to be what? 874. And 36 times 25. Let's see, 3,600, 900. And what do you get over there? That would be 1774. Oh, I got to do some more work here, don't I? I got to divide both sides by 1774. And let's do that. Now, before I do, I want to point out, I think I noticed something about 49 times 36. We'll see, 6 times 9, 54, right? 6 times 4 is 24, 29. Let's see, 3 times 9 is 27, right? And 3 times 4 is 12, 13, 14. Let's see, 4. I made a mistake. It's 64. Sorry about that. Yep, I made a mistake there. 9 and 7, the reason I made a mistake is because I'm looking at my work now and it's not giving me what I wanted to. I'm always thinking the numbers got to be easy. That's going to be 16. Let's see, 4, 5, 6, 7, 17, 64. So what do I get over here? X minus 1 squared over, well, that would be 36 then, right? Plus y, whoops, another mistake, I put a square over there. Y minus 5 squared over what? Over 49 is equal to, whoops, this is 64. Sorry about that. All right, that's the answer given to me over here. There we go, I'm just practicing. It says find the center of that. Well, the center couldn't be any easier. The center of that's pretty simple. The center is going to be 1, 5. I want to point out that's listed for me right over here. Now, I got to be honest with you. A lot of students have a tough time with the vertices and stuff. And what I'm going to do is I'm going to put a little graph down for you. As I do the graph, though, I want to point out, I'm going to put some points down for you. And someone says, why do you put points down? I think they're going to be really easy points to put down. And one of the points I want to put down is when x is 1. And when I point out when x is 1, I'm looking at this term over here. All right, and that would disappear. And that's not bad. When that disappears, not bad. So really what I'm trying to do is I'm trying to make this term here to be equal to the number 1. And the only way that happened is if the top number became 7 squared. So I'm going to say that occurs at -2, because that would be -7 squared. And the other place it would occur at would be, let's see, 1. And I want to make it 7, so that would be what? That would be 12, wouldn't it? All right, let me do another one. And now I'm going to make the y to be 5. And there'll be 2 points that satisfy that as well. All right, and we'll talk about what the vertices are. They're along the major axis, or the longest axis in the problem. And we'll talk about that by looking at our points that we get. All right, so I got the center down. I haven't got the vertices down yet, though. So if I say y is 5, this term disappears. And now I'm working on this one over here. I want to make it top to be 6, because 6 squared is 36. What would that be? Well, it could be -6 too, right? So I'm going to say -5. And what else would it be? Let's see, 7, right? Now I want to look at this over here. I'm talking about the length of the distance between those 2 points. And that would be what? -5 to 7 would be 12 units, right? And what's this one over here? Well, that's going to be 14 units. Which one's longer? The 14. So these are the vertices. All right? Let's make sure I got those down. I got the 1, -2, and the 1, 12. Yep, I got those down. The foci, a little more complicated, but not that bad. I'm going to go along the major axes. So they're along this axis over here. So I'm going to say I know the x-coordinate. It's 1. I know the x-coordinate, the other focus. But then it becomes the problem is how do you do that? And what you do is you take the difference of these two. All right? So what's the difference between 36 and 49? It's 13. And that's what c squared is equal to. So what's c? C is root 13. Now certainly plus or minus. Let's write this down. So what are you going to do? In from the center, what we do, it's going to be 5. We're going to go in, plus root 13, and 5 minus root 13. And that answer is right here. All right, we're doing okay. All right, let's do the next one. This is 37. I know this is long and tedious for some students. The more effort you put into your studies, the better it gets for you. This says rewrite the expression so it's not fractional in form. And this can get really tough, by the way. But my assumption is it can't be that bad. So I'll write this down for you. And certainly when I'm writing these things down for you, you may wonder what I'm going to do over here. I don't know. There's one thing you could do, right? Think in terms of sines and cosines. I'm not sure if that's going to help you or not. But I'll write this down. So it's going to be sine squared over cosine squared. And this would be 1 over sine squared. I'm sorry, 1 over sine. I'm sorry about that. Plus 1. Now, by the way, I can't say that really helped me much, but I can do a little bit of work over here. And if I were to look at that, I'd multiply top and bottom by sine. And if you multiply the bottom by sine, you need to multiply the top by sine. Now, again, if this goes nowhere, I can easily erase it and come back to it. And what do you get over here? Well, you get something pretty simple. You know what? I don't think I want to do that because it seems like it's going to be a long road to nowhere. I'm going to erase this now. I'm going to start talking about identities right over here. And one of the identities I'm looking at, oh, I'm sorry, I shouldn't have erased that part. I'm sorry about that. I'm looking at identities about the tangent squared, the Pythagorean identities. Let me write this over here. Sine squared x plus cosine squared x is equal to 1. I think you've seen that before, right? I'm going to divide by cosine squared. What do you get? Tangent squared x plus, well, let's see. That would be, if I'm done with cosine, that would be, let's see, 1 equals secant squared, right? Let's see if I did that right. Sine over cosine. Yeah, I did it right. I'll write that down. So what's tangent squared equal to? Secant squared minus 1. You know what? That might be a dead end too. So I'm going to try something else. I'm going to keep this up here though. I'm going to try to multiply the bottom by the cosecant, its conjugate by the way, minus 1. Cosecant x minus 1. It's still going to be Pythagorean in the end. But I'll look at the top, and the top really I'm not too worried about. It's tangent squared times the cosecant minus 1. And what's the bottom going to be? The cosecant squared x minus 1. So I'm going to see if I can get that with a Pythagorean identity. I'm going to divide by sine squared. And what do you get? Well, let's see. What do you get? You would get, if I divide by sine squared, you get 1 plus the cotangent squared x equals, well, I'm dividing by sine squared, so it's cosecant, right? I think I got it. I'll write this down for you. So what do I got? Tangent squared x cosecant x minus 1 over, well, cosecant squared x minus 1 is just simply cotangent squared x. So what do I got over here? Something pretty simple now. Maybe I shouldn't say simple. Something that they wanted. And I'll go back and read it to you. The fourth power of x times the cosecant of x minus 1. I'll look at the key later, by the way. It says rewrite the expression so that it's not fractional. And that's not fractional, by the way. Let's take a look what they got. And they wrote something a little bit different. And I'm wondering if I did okay. And I think I did okay. I did a little differently than they did. But let's look at their work. But this is fine work. And again, I kind of fished around for something to do. This is fine. And let's see what they've done. And I guess they did what I did in the beginning, right? You got this part over here. And you got tan sine x. Yeah, they did okay. They multiply by the conjugate. Let's see what you do over here. Multiply by that. You get the bottom minus sine squared x, which is cosine squared. Yeah, that's fine. They did it. They did it too. There's some variance in the problem, but it's not bad to do that. Can't hurt to see that. Now, again, I want to bring that's a good point. Sort of like when I first started the problem, I was doing this, and I said, oh, gee, it looked like too much work. And then I start doing things with the Pythagorean identities. It varies, all right? Day to day, it might vary for me. So in this day, I did it this way, and the day I do it another way. And that's really something that's important when you're on exams. You got to have some experience with working problems. And that's why we practice. All right, this is a parabola. And I want to point out it's a parabola taught at the Math 120 level. This is Math 120 over here. I forgot to write that down for you. Let me make sure I wrote this one. Yep, Math 120. I already did that. So let's keep going. And let's take a look. So I'm going to do my complete and square business over here. And what do you get? Y squared minus 12y. And then I'm going to put down 16x minus 20. I'm going to complete the square by taking half of minus 12, which is minus 6, and square it, which is 36, and adding 36 to both sides. Now, generally speaking, they write problems to be really, really nice, which I'm always thankful for. This is 16x minus, let's see. Oh, not minus, it's plus 16, right? Boy, that was convenient. What do you get over here? Y minus 6 squared. I'm going to factor out a 16, and you get x plus 1. All right, now I want to write it as the 4p, because that's how they taught you in Math 120. So y minus 6 squared 4 times the p. Well, that'd have to be 4, because that's 16, right? And x plus 1. So this is where I could actually, write down answers really quick to this over here. Like I can write the vertex down. I mean, really quickly, by the way. What's it going to be? Minus 1. I'm looking at the standard form to do that, by the way. And what do you get over there? Minus 1, and then you're going to get 6. Now, I'm the kind of person that has to visualize this, but you may not be. You may say, I don't need to visualize that. I can write the rest of the answers down without doing any of that visualization stuff. But I'm gonna visualize it. And what do I got? I got minus 1, and then I got 6 up. So I'm going to say maybe something like this over here. That's where the vertex is. Now, how does this open up? It's going to open up sort of like this over here. And I'm saying that's a really rough picture. And what do I know? There's a directrix over here and a focus over here. But then I got to wonder, what is it going to be? And this is the vertex. The vertex is minus 1, 6, by the way. I got to go 4 units in. And what's 4 units in from that point? That would be what? The y is still going to be 6. But what would you get? Well, 4 units in from minus 1 is 3. So that's where the focus is. Let's see if they got that. Yep. Let's put the directrix down. What am I going to do? I'm going to go 4 units to the left of that. And if I'm at minus 1, 4 units to the left would be x equals minus 5 for the directrix. And they got this over here. They also list a p down for it. They don't have to ask for it, but they did list it. All right, calculate the composite function. determine their domains. A little more complicated when the domain's in the problem. But let's write this down. Domain of this over here is going to be 0 to infinity. And the range of this over here is going to be 0 to infinity. That's f, by the way. Let me do g. G's domain is going to be all the real numbers. And the range of this thing is going to be here, all the real numbers as well. So let's put this down now. And let's put down f of g first. F of g of x equals f. What's g? It's x plus 2. What does f do to it? It takes the root of it. Now, by the way, for most students, that's all they can get. That's all they can get. When I teach math, by the way, this is Math 119. I've been teaching Math 119 for a long time, and I realize a lot of students they're bogging down in it. They can't go beyond that. Oh, by the way, don't think that's true for every student in pre-calculus. I'm just saying my experience has been a large number of students can't go beyond that. What I got to do is talk about what's happening over here. And the thing I'm going to talk about is G takes in what numbers? It takes in all the real numbers. And what does it sit back? It tries to give G all the real numbers. But here's my problem. G tries to give F all the real numbers. F can't accept it. So what does F accept? I'll write this down for you. F accepts from G only those numbers that are greater than or equal to 0. And what would that happen when x is greater than or equal to minus 2? So the domain of this over here is going to be minus 2 to infinity. All right? Now, is this answer listed for you? Right over here. All right? Right over here. Now, let's do g of f. What's that going to be? G of f of x. What's f of x? The root of x. What does g do to that? It doubles it. I'm sorry, it doesn't double it. I'm sorry. I'm thinking of a prior problem. What does it do? It takes the argument and adds 2 to it. So it's going to be root x plus 2. Now, before I do anything, I want to point out, I got to erase my circle over here because it doesn't look like the right answer. But I got the right answer. Now, before, when I circled it, it looked like the root of x plus 2. So I got this over here. This is good. But I got to do the domain thing over here. And what does f take? Well, let's take a look at it. Well, f takes what? It takes 0 to infinity. And then what does it try to do? It tries to give to g 0 to infinity. G can take anything. So this is the domain. So the domain of this guy over here is 0 to infinity. And that's certainly listed over here, by the way. All right? So we're done with that. Let's look at the next one. This one's a solving problem. And you need to know the double angle formulas. I'll write this one down for you. Sine of theta is equal to, what do you get there? 2 sine theta cosine theta. Now again, I really kind of warn students about this. Don't divide both sides by sine theta. That's a very dangerous thing to do because you have no idea what sine theta is. So what I'm going to do over here, I'll write down 0 equals 2 sine theta cosine theta minus sine theta. A typical question students often have at this level of the game is, how much do I need to remember from prior courses? As much as you possibly can. I do realize that sometimes students can't remember a lot, but the bottom line, that impacts your future greatly. What do you get over here? This would be sine theta. And what do you get over here? 2 cosine theta minus 1. By the way, it's a relatively simple question, but they threw something into this thing which says I just have to give the answers between pi and 2 pi. Well, that's not so bad. I'm going to write this down now for you. Now the sine of theta looks like this over here. And when does it equal 0? I'm using a zero product rule here and here. So I'm going to say theta is equal to pi, and it also 2 pi. They both work. All right? That's good. We'll look at the answer later, by the way. So let me take a look and make sure I want to make sure why they did something here. Oh, I'm sorry. I shouldn't have included 2 pi. And I'm looking at my answer, by the way, and I want to tell you why it says over here don't include it. So I have to erase that now. Sorry about that. Now what I want to do is I want to do the next one, which is when the cosine of theta is equal to a half. Now someone says, when would that occur? Well, the cosine of theta looks like this over here. And by the way, it equals a half at this level over here. But what's nice about this, when I'm between pi and 2 pi, there's only one solution to it. Let me write that down for you now. It's going to be a reference angle. I'll put this over here, theta sub r. And what's the reference going to be? Well, I'm going to talk about degrees. And for the cosine to be a half, that would have to be 30 degrees. But I'm over here. So someone says, what are you between? I'm actually between 270 and 360. So it'd be 330 degrees though. So theta is 330 degrees. And let me take a look at that. 330 degrees. Pi over 180. I think I made a mistake here. Oh, you know what? I did make another mistake. It's not 30 degrees. The reference is 60. Let me go through that. And I'm sorry about that. I should have drew a picture for you. Cosine, 60 degrees. Sorry about that. So what's the angle going to be? Not 330. It's going to be 300. Sorry about that. It happens, though. Mistakes happen, and we try to not make too many mistakes. So how do I do 300 degrees? I get a radian measure, right? So 300 degrees times pi over 180 degrees. I would divide by 60 degrees. That would give me 5 pi over 3. Got it. All right, let's go to 41. 41 is another Math 120 question. By the way, this is Math 120. We have extensive websites up there for those students that have not mastered the material. They can go back and do it. Unfortunately, what happens to a lot of students is they might have a teacher that really didn't take this seriously. By the way, when I say that, not only do teachers sometimes take this stuff seriously, but students may not take it seriously. And your educations are in your hands, regardless of what your teachers are doing. We're hoping your teachers are taking this serious enough that they actually can do this material at the board. Of course, you need time and effort to study that, and I would recommend also reading books about it. But let me write this down for you. 4 pi over 3. I'm going to do 180 degrees over pi. Pi's cancel. 3 goes into 180, 60 degree time, so it's 240 degrees. So someone says, why do you do that? I want to visualize it. And so 240 degrees is going to be 180 plus 60. That's a 60-degree reference triangle. And what's the cosine over there? Well, looking at that, that's going to be minus 1/2. Let me write this down for you. So I got another problem in my hand. And someone says, what's your problem now? Let me erase my baby work. Is I need to know the arc cosine. And some teachers are of the opinion that students should memorize that. And that's fine with me. If you memorize things, I'm not opposed to that. What I'm opposed to putting a wrong answer down. But I don't want to memorize anything. I want to think about it. So I'm going to think about it. The invertible region cosine looks like this, and minus 1/2 is down here. So I know it's between 180 and 270 degrees. And then I'm wondering what's the reference angle, and the reference is still going to be 60 degrees. But what do I get over there? I'm sorry, I made another mistake, and I'm really must be exhausted or something. Sorry about that. That's 90 degrees and 180 degrees. Sorry about that. So what's the angle going to be there? Well, the reference is between 90 and 180, but I'm sorry, the angle is between 90 and 180, but the reference is 60. It's going to be 120 degrees. By the way, we don't like to speak in degrees, so I'm going to convert it to radian. That's going to be pi over 180. I would divide by 60 degrees, and you would get 2 pi over 3. Okay? This one's solving inequality. Oh boy, God, this is a really easy one. Here's the deal, though. A lot of students, although they're taught a method, they say, I'm not going to do that. I'm going to do what I always like to do. That's a very unfortunate thing because you get wrong answers. And you really got to be careful about that. When you're getting a wrong answer, you got to stop yourself. You got to say, I don't want to get wrong answers. What's the point of that? I'm going to do the work. And the work you were taught in Math 119, this is math 119, was you were taught to solve this thing, whoops, sorry about that, which is going to be a rational inequality by comparing it with 0. Let me do that for you. Relatively simple to do. You were told to get that to be one term completely factored. This is x cubed, and it'll be 1 minus x squared. Now, what I mean by completely factored, let me write this down for you. This would be 1 minus x, 1 plus x, and this resorts to sign analysis. How do you do sign analysis? You list the zeros of the top polynomial, which is plus or minus 1, and you list the 0 of the bottom polynomial, which is simply just 0. Now, the zeros are easy, guys, to do. It's 0 at minus 1. It's 0 at 1. Why am I doing that? It's equal to it. But it never, don't circle the 0, by the way, because it's division by 0. And now I just do sign analysis. So after 1, I'd pick probably 10, and that would be negative. Now, that certainly satisfies the inequality. I shade that in. Between 0 and 1, I use a half, and every single factor is positive, so I would not shade that in. I would use minus a half, which is the next interval, and minus a half. And by what I mean by that, let me write this down for you. This is a minus half over here. I've already checked out a half, and that's certainly good. And over here, I think I checked 10. Over here, I'll check minus 2. And we're hoping this is a review for you, not learning. So we've done 10. That was negative. We've done a half. It was positive. Now we're on minus a half. And minus half would give me a negative number. Again, simple arithmetic over here. If I did minus 2, what do I get? I get a positive number. We want it to be negative, so it's over here. Now, do mistakes happen? All the time. I'll write down my answer, though. And then we'll check it with the key. And if I got the wrong answer, I want to rectify it. And I want you to rectify it, too. Just don't say whatever. All right, let's take a look at our answer and see if we've got the answer. And I'm looking at it over here. I want to be honest with myself. I did get the first one, in union 1 to infinity. All right, this one's a quadratic inequality, relatively simple. What are you going to do? What you did in Math 119. I'm going to expand it. You're going to get 1 minus 2x plus x squared less than or equal to 10 minus 2x. I bet this is going to be easy to do if I just try. You're going to get x squared. I'm going to subtract away, I'm going to add 2x to both sides. That's nothing. That's good news. And then what do you get? Let's see, 1 minus 10 is minus 9, right? Wow, that just turned out to be too nice. The zeros of that are plus or minus 3. And let's go to town testing it. And I'll pick a number like between minus 3 and 3 with like a 0, and that's clearly negative. That works out beautifully. A number after 3 like 10, plug it in, that's positive. That's no good. And a number below minus 3 like minus 10, when you plug it in, it would turn out to be a positive number. Now, when I say that, we're talking about this thing over here. So I got my answer. Let me just shade this in because there's zeros there. And my answer over here is from minus 3 to 3. And that answer is listed for you. All right, this one says graph. Wow, that's going to be a tough one. So let's take a look. And I'm going to say, looking at it, I certainly would like to get the domain of it. And to get the domain of it, I'm realizing that, you know, the first guy over here, its domain, the first guy, its domain is going to be 4 minus x is greater than or equal to 0, which means this over here. That means the x is below 4. Now I'm going to do the other guy over here. And sometimes, why is domain so important? It kind of restricts my picture. It really does. Now what do you get over here? This has to be greater or equal to 0. It's a little more complicated, but I'll put it down for you. It's going to be minus 1 to 1. That's where the zeros are. Now if you took 0, that would be negative, so that wouldn't be satisfied. But these are satisfied over here. And I'm just doing simple sign analysis. And then I'm going to put the other guy down next to it. It's tough, though. And what is it going to be? The x has to be greater than 4. I'm sorry, less than 4. Sorry about that. So what do I know? I know this picture here. I know it. I know the picture here goes from minus infinity up to minus 1, union 1 to 4. And what I'm going to do is I'm going to basically start to try to draw a picture of it. And I'm not going to say I'm going to do a great job of it. But what I'm going to say is we're not looking for great jobs. We're looking for some reasonable job. All right? Let me erase my baby work. You know, that really babyish work. It's important work, but it's still babyish work. Let me erase this over here too. I need some space over here. And I'll put a picture down. Now I'm gonna start at 4. Now if I put a 4 down, what do you get? Oh, this is gonna be tough. So I got a point over here at 4. Put 4 over here. And what would you get at 4? If I plug it in, I get 0 plus 16 minus 1, which is 15. So I'm going to say the point's up here somewhere. So I'm going to say the point 4, and I get root 15. Now, root 15 is roughly 4, by the way. All right? I'm going to go to 1 now. And what do you get when you go to 1? 1's over here somewhere. You would get what? Root 3. I'll put that down for you. That's a point, by the way. Now, someone says, I wonder what the connection is between those two guys over there. And that's the tough part, by the way. When you study calculus, we'll get a better connection. But right now, I'm going to, roughly say, maybe something like this over here. All right? Something like that. Now what I'm going to do is I'm going to do minus 1. And what would that look like? Well, that would give you what? That would give you root 5. Here comes my trouble now. Where am I going to go now? Well, if I go to minus infinity, I hope you realize that this thing just keeps going up and up and up and up and up forever. So I'm going to say this is my rough pre-calc. Now someone says, I wonder what a machine would look like. Well, let's take a look. This is going to be figure 2 on page 32. And I see it over here. Now, I realize somebody's going to argue saying, oh, your graph isn't as good as this one over here. I never claimed it would be. This is a more precise graph, and it's one that you want to be able to learn to do on your own. All right, now what I mean by that, using a tool. Now, granted, I didn't do a bad job. All right, I just didn't do a great job. There's no doubt about it. All right, but I got to be honest with you, my graph isn't that bad. It looks sort of like that one over there. I got the general shape of it. All right, let's go to 44. And let me see how many problems I have to do. This is the third set of it, and I know it's tough. Very tough for students. It's too much work for me. I don't want to do all this work. I want to just warn you again. You really want to do a job you like doing. So if you don't like doing these jobs, you really have to find another job to get. I kid you not. Let's write this one down for you, and I'll write it down for you. They want the difference quotient. They gave it to me, so that's not a problem. So what I got to do, I got to do f of 2 plus h. Let me write this down over here. And that's going to be 2 plus h cubed minus f of 2. Well, that's going to be 2 cubed. And what's going to be over h? With the understanding that h is not equal to 0. Well, you know what? This is something you did in math 119. But I want to point out, you also did the binomial theorem in math 120. So I'm kind of combining two things. But you don't have to. You could just do it by math 119 methods. And I'm kind of looking at it, and there are many ways to do it, but I'm going to write it down for you. And again, I'm doing this over here now. And this is going to be easy peasy lemon squeezy if you know your material from 119 and 120. So it's going to be 8 plus, well, I got to do the next one. It's going to be 3 times, let's see, 2 squared. That's 12. 12h. Plus, the next thing is going to be 3 times 2, which is 6h squared. I'm using the binomial theorem to do that. And then you're going to get h cubed. I just did this part over here using the binomial theorem. They learned in math 120. And what's minus 2 cubed is minus 8. Now, what's nice about this, and I do mean this disappears. And that's really good news for me. And I'll tell you why. I can now divide through by h. And when you divide through by h, because h isn't 0, you're going to get 12 plus 6h plus h squared. I'll put a box in this, and I want to look at the answer key. What they say, 12 plus 6h plus h squared. Not bad. All right, this one's an inequality. It's math 119. It's an absolute value inequality. The method they taught you in math 119 is to isolate the absolute value, and this would be 20. The next thing is to understand. But again, a lot of teachers teach it. It's not an understanding problem. It's a memorization skill. I'm opposed to memorization, but I wouldn't know the difference. I'm reasoning. It says the distance this object is, which is 14 minus x, must be within 20 units of the origin. Let me write that down for you. To be within 20 units of the origin is between 20 and minus 20, but the object is quite strange, by the way. It's this thing over here. I got to solve this. I'm going to solve it by subtracting 14 from both sides. And then I'm going to multiply both sides. I shouldn't say both sides. It's all sides. It's 3 sides. I'm going to multiply all 3 sides by minus 1. What do you get? 34. The direction of the inequality changes, and minus 6. I'm going to put down the intervals now. It goes from minus 6 up to 34. And the x is between those. So the interval is going to go from minus 6 to 34. If you just want to write down the inequality, this is fine over here. Let's take a look, and I see the answer. All right, 46 is a log equation. Log equations can be easy. They can be nightmarish. We see it and have to check our work when we get it. This is log base 3. I'll write this one down for you. Log base 3. I'm using the rules of logs. That's 2x plus 1 times 2x minus 1 equals the number 1. I'm going to write the log as an exponential problem, and that's 2x plus 1 times 2x minus 1 equals 3 to the first power. I got to multiply this out because this looks like it's quadratic in form. It's 4x squared minus 1 equals 3. And this looks like it's going to work out pretty nicely for me. And what do I mean by that? It's 4x squared minus 4 equals 0. I will divide both sides by 4, and you get x squared minus 1 equals 0. And this looks pretty simple to me. It looks like x is plus or minus 1. I'm not going to say that's the correct answer, by the way. I'm just going to say that's what my work led to. But my work could be wrong. So I'm going to check them both. I want to check x equals 1 first in the original equation. And what do you get over there? Well, you would get log base 3. From checking 1, that would be 3. That's fairly simple to do. And you would get log base 3 of 1. And they say it's equal to 1. Well, this is 1 plus 0 is equal to 1. This is a good answer. Let me try the other one now. And who knows, maybe it's a good answer too. What do you get? Log base 3. Well, that would be minus 2 plus 1, which is minus 1. And right now I know I'm in trouble. And why is that? It's not a real number. And we're only dealing with real numbers for logs at this level. So let me cross this one out. We only got one answer, x equals 1. Let's take a look what they've got. They do say that, and they say that you should check it. Now, they also mention about complex numbers. Please don't worry about that at this point in the game. This one's a rational function, and they're asking specific questions about it. Now, I want to point out they've been quite generous in doing this. They're giving me this, and they're giving me the factored form of it, which makes it really easy for me to answer the questions. Where are the questions, where the x-intercepts in point form? Well, that's where the top becomes 0, and it's at 1 and 2. So these are the x-intercepts, fairly simple. What's the y-intercept? Well, that's also simple. Just set x to be 0, and you would get 0, 2/3. The equation of the horizontal asymptotes, I'm going to write down some work for that over there. The work for that is limit, and it's something you did in Math 119. It's the limit as x goes to infinity. The recommendation is you divide it by the highest degree variable, and if you did that, you would get 1. Highest degree variable is x squared, by the way, minus 3 over x plus 2 over x squared. On the bottom, you're going to get 2 plus 5 over x plus 3 over x squared. And the limit of that, fairly simple, just 1/2. So I'm going to say that's good, but I'm also going to do the limit as x goes to minus infinity. Now, imagine some of your teachers said, oh, don't bother. You should. You should bother with both directions, by the way. You should never assume it works. Although there's some truth to that, but it's not always truthful. This is also 1/2. So I'm going to say it's y equals 1/2, and that's horizontal. It looks like this over here. Equation of the vertical asymptotes, a little more difficult. And I'm going to say most of your teachers just simply said it's when the bottoms become 0, provided the top does not simultaneously become 0, and that would occur at minus 1, and it would occur at x equals minus 3 over 2. But I do want to point out there's more to the story than your teachers might have told you, the fairy tale version of it. You should do limits. And the reason for doing limits over here is to verify that. So I'm going to write that down for you. The limit as x approaches -1 from the right side, and yes, you did this in Math 119, at least if your teacher was responsible enough to teach the course. And when I say that, a lot of times teachers, what they do is they say it's not worth covering things that are hard to describe. These are not very hard to describe. I want to point out what I mean by that. If I were looking at this thing over here, I'm looking for sine of it first. So I'll put down -1, and this is the left side, and this is the right side. So if you're looking at that, it basically kind of boils down to sine analysis. And, you know, I know it's tough, but you've done a lot of sine analysis already, and I'm hoping you have some feel for it. And I'm left at -1. You know what? Let me do all the sine analysis for you. Just why would I just simply do one when I can do it all in one shot? So where's it going to be? It's going to be at 1. It's going to be at -1. It's going to be at 2. This is important, by the way. And then what do you get? You're going to get what? You're going to get -3/2. I'm sorry, this is +1, that's -1. -3/2 is over here. I'm going to point out some test values over here, like 3. You're plugging it in here. You get positive, 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 positive. I'm going to pick a point here. I'm going to pick 0. Someone says, why'd you skip the other one? There's a reason for that, but I'll get back to it later. So if you put 0 in, you get negative times a negative on top, which is positive, and bottom you get positive. That's all positive. This is important information, by the way. Now, if you go below -3/2, like, you know, -50, you get negative and negative on top, and a negative on bottom. Everything's going to be positive. I want to do other ones over here. I'm going to put 1.5 over here. And what do you get? Positive, negative on top, positive on bottom is negative. All right, I'm going to go between -1 and -3.2. And I'll say a good test point over here would be -1.1. Plug it in top, you get negative, which is positive. On bottom, 2 times -1.1 is -2.2 plus 3 is positive. And then you get a negative, so negative overall. So someone says, oh, that's a lot of work. It's not. It's not a lot of work. It's work that you want to be able to do on your own. So I'm going to say from the right of -1, I'm going to point out what I mean by that. This is the right side of it. What's the limit going to be? Plus. I'll write that down as a plus sign. Now to the left of -1, that's over here, what's the limit going to be? Negative. Now this is where we know these things are blowing up, so I'll put a plus infinity down. Let me do another limit for you. And I know it's tough, but we're trying to encourage it. We're going to go towards the number -3/2 from the right, and we're going to do the limit as x goes to -3/2 from the left of f of x. Well, what's nice about this, I got a sign analysis over here. To the right, it's going to be negative, and to the left, it's going to be positive. I'll write that down for you. And these are blow-up problems. We're going to infinity. We're dividing by zeros. All right? So next one says use the information for and sign analysis. Well, you already got to sign this down. But I want to point out what's the information is basically drawing a picture. All right? Now someone says, oh, you drew the picture for me. Thank you. No, you can do the picture. I want to point out what I'm doing in the picture. I'm going to put all the information down we got. Someone says, what information do you get? The x and y intercepts. So 1, 2. I'll put this over here for you. I'll put this in for you. X-intercept 1 and 2. And what else did I get? I got a y-intercept. I want to point, if you can't remember that, you go back and read it. That was 2/3. 2/3 is up here. I got those points. I'm going to put the asymptotes in, or the asymptotes over here. If you remember, the horizontal asymptote was y equals 1/2. I'll write that down for you. We got the vertical asymptotes, and the vertical asymptotes were x equals 1, and the other one was x equals -3/2. All right? We also did sign analysis, if you recall, and someone says, I don't recall ever doing that. We just did it. All right, it's right over here. You know, what has got plus, minus, plus, minus, plus? Clearly plus over here. Let me just outline that for you. Now someone says, what are you doing now? You're just drawing over your picture. Well, I want to point out they're asymptotic behavior. So really what I do is just connecting behavior. Now it's plus minus. You know what? I don't see anything over here. But I got to be honest with you. There's something over here too. I just don't see it yet. So plus minus plus. I'm seeing that over here. Whoops, sorry about that. This over here actually goes below. And then it's going to, that's minus, by the way. And then it goes positive and it goes towards the asymptote. Now someone's going to say, I don't see what happens over here. Well, I'm going to look over here. Between these lines, somewhere down here, it looks like this. And it does. You just don't see that. All right? Okay, let's keep going. I know this is difficult. Let me look at the next question up. This one over here looks relatively simple. The arc cosine, ooh, maybe not. So what gives me a ratio of 1 over root 2? That would be 45 degrees, right? Or pi over 4. Let's look at our king. Got it. Let's do this one over here. And I'm going to put this one down for you. And that's 5 pi over 3, right? 180 degrees over pi. The pi's cancel. And that's going to be 5 times 60 degrees, which is 300 degrees. Now someone says, why do you go to the trouble of doing that? And the reason is that you kind of need to know that. And 300 degrees is way over here. And it's got a reference of 60 degrees. All right? So the sign in that quadrant is going to be negative. I'll write this down for you. Arc cosine of a negative number. And it's 60 degrees, so root 3 over 2. And it's negative. Then the question is, what do you do there? Well, you need to know the invertible region of the cosine curve, and that looks like this over here. And that's going to be some value over here. And that's between 90 degrees and 180 degrees. And what would be the reference of that number? Well, the reference of that number would be 30 degrees. So the angle would be 180 minus 30, 150 degrees. Now you should convert that to radian measure. Let me write this down for you. That'll be pi over 180 degrees. And I'm going to divide. I'm going to divide by, I don't know, maybe 10 first. You get 15, or 10 degrees, by the way, pi over 18. And then I'm going to divide by 3. You get 5 pi over 6. Okay? Let's do the sum. Again, more difficult. And again, you may not remember these things over here. It's not that bad. Let's write this down. And the one thing I would really hate to see a student do is write down term by term. In other words, this would be 2 times 48 minus 1 plus 2 times 49 minus 1 plus 2 times 50 minus 1 plus yada, yada, yada. There's a lot of yada, yada, yada's there until we get to the end, which is 2 times 70 minus 1. All right? Now, granted, I'm not opposed to you doing that. I'm kind of looking at that, and maybe that's not such a bad idea. But what I would do now is I'd factor out a 2 from all those terms. And what are you left off with? 48 plus 49 plus 50 plus yada, 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 all the way up to the number 70. And then you get a bunch of 1s there. And the question is, how many 1s would you get? And I know it's tough to count, but if you're starting at 48 and getting to 70, it's going to be 70 minus 48 plus 1. That's the number of terms you'd have. And what would that give you? That would give you 23, right? So I'm going to say there's 23 of those 1s. All right? Now someone can say, oh, gee, what are you going to do now? Well, it looks like an arithmetic one, doesn't it? This is arithmetic. And I know there's some of an arithmetic. I'm going to write this down for you. And what are you going to get? It's going to be 2 times, there's 23 terms, over 2, and then it's going to be 70 plus 48. And again, you may not be able to recall these formulas that you learned in Math 120, but it's not that bad. And then you're going to get minus 23. Yeah, I know it's exhausting. The 2's cancel, and then you do the arithmetic. I'm going to factor out a 23. And what do you get? 70 plus 48 minus 1. Let me keep going. 23. 70 plus 47, right? Let me write that down for you. That's a 7 when I add together. 117. Well, let's see if we can do that. That's a lot of work, isn't it? So you can get 2300, 230. I'm just doing multiplication, by the way. 23 times 100, 23 times 10, then 23 times 7. That's going to be 140 and 21, 161. We have the key to look at. 6 and 3 is 9. Let's see, 3, 4, 5, 6, 2, 6, 9, 1. Right over here. We're doing okay. All right, this is mathematical induction. I'm going to read this to you. And PMI is taught in Math 120. Let me make sure I told you about this one already. This is also Math 120. And you may have to go back and review. And it's really a burden for a lot of students to go back and review. And the reason for that is if you didn't master the material and you keep going forward, it's going to be really, really tough for you to be successful. All right. Now, I realize this is falling on deaf ears, but the bottom line is we have an obligation to at least say it. All right. Even if we're talking to a wall, we need to say it. So this one's induction, and what you need to do is verify that it's true for n equals 1. And that's fairly easy to do, by the way. For a lot of students, that's confusing, though. If n is equal to 1, what are you going to get? On the right side, you get 3 to the first power minus 1. And that's not so bad to do. But on the right side, a lot of students say, I don't even know what to do if n is equal to 1. Well, what you're doing over there, if n is equal to 1, the question is, where would you end at? You'd end at, well, 3 to the 0, which is 1. So you just get 1 here. That's all you'd get. And now what's 2 times 1 is 2. What are you going to decide? 3 minus 1 is 2. And that's often confusing for students, that first step. And that's true. P1 does work. And then what are you doing? You're assuming PK. You just simply write it down. You just write down the proposition they gave you. But what you're doing over there is you're writing down, instead of n, you're writing down k. Then what you're going to be doing, and this is the tough part, is trying to figure out how pk will eventually lead to pk plus 1. Well, I say before you do that, write down pk plus 1. And pk plus 1 would look like this over here. So you need to find a path from here to here. And I'm looking at that, and I'm wondering, how would I get that to work? So I'm looking at it, and really, it might befuddle you to the whole point of being befuddled. But I got to be honest with you, what am I looking at? I'm looking at, I got to get the next term going. And what's the next term going to look like? It's going to look like this times this. That's what the next term looks like. So what do? I add this to both sides of the equation. So what do? I take this, and all I do is I add that to both sides of the equation. And here comes the problem. I could do that, but I'm not saying it's truthful. In other words, I'm not sure it's lead to where I want it to lead. I'm kind of looking at that, and let me look at this side over here. What do I get over here? This is the side I'm really struggling with. I'm looking at the 3k thing, right? 3k times what? That would be 1 plus 2. And then I get minus 1, right? What's 1 plus 2? 3. So what does this really lead to? This leads to 3 to k plus 1 minus 1, which is exactly what I wanted. And by the way, this side is really a no-brainer. So we've proved it. And what do we say when we prove something? QED. All right, so here's the deal. We spent, I spent countless time doing that. Someone says, oh, thank God you did that. I didn't feel like doing any of that. No, you got to do that. It's not me doing it. You need to do that. You need to practice, all right? And here comes the big problem. There's more practice to come, all right? Thank you for paying attention.